he is 30 and he is using the Dexcom sensor and you know, he's on the, what is it? Whatever the pump he's on. Oh my gosh.
Probably Tandem.
Tandem, thank you. Thank
Yeah.
you. Reagan, are you still having?
Now I'm back.
Okay.
Can you hear me?
Yes.
Yeah.
Yay. Sorry. That was ridiculous. All these things were not plugged in. I had unplugged them and forgot. Anyways. But yeah, my daughter Willa was diagnosed at almost 5, and she is 15 now, and she's actually she's looping. She's been looping for, it'll be 2 years this summer. Things are good with it actually, but wow, I really can't wait for FDA approval. So she's using the Omnipod obviously, and CGM and all that. So.
All right, Sarah, do you want to tell us about Judy and?
Yeah, I'm the grandmother of Caitlin, who I take care of her and her younger sister while their mother works. Caitlin was diagnosed at age 2, and she is now 9 years old. She uses an Omnipod and the Dexcom G6, and she has not switched to OmniDash yet because her mom still has a whole lot of the regular standard pods and doesn't want to throw them out in the garbage, you know, because they were so expensive to begin with. So, but she is under really, really, really excellent control. We're just delighted. And she does a lot of exercise, and also she only eats sweets and stuff like that if she's low. So she has a very strict diet and seems to be perfectly happy with it.
Sounds good.
Great. Kimberly's probably working and is probably, you can talk. Okay.
I'm here. Yep. I am working, so I'm going to be dual tasking today. But my name is Kimberly Davis, and my son Crosby was diagnosed at 2.5. He's 5 now on the Dexcom G6 and the Omnipod. The original, well, not the original, not the Dash.
Okay. Okay.
Thank you.
Good morning. I'm Linda. I'm also going to be muted. I'm scurrying around. I'm multitasking. My son Jack was diagnosed 13 years ago, and he's also on the pump. And hopefully in August, I think our insurance will allow him to move along. So I think he's looking at the Tandem, but it's still up for discussion, I guess. Now that he's 24, he makes a lot of his own decisions about all of this. So.
I'm going to jump in. I joined late. I'm Susan Leibach. My son is 19, and he was diagnosed when he was 11. And he's currently on the T-Slim, but he refuses to upgrade to Control IQ, so he's still just using Basal IQ. And he's bigger than I am, so he gets to decide.
That's
yeah, he thinks he can do it better, but he can't. So, but I have to pick my battles, and I'm not.
Yeah.
Susan, can you hear me, Susan Gaffney? Do you want to? Yeah. Go ahead and just tell us what Katie is doing.
Well, Simone, you're going to have to help me because she's on. I
Katie
forgot.
is an adult
who's like 30 something, but I'll know it if you tell me.
Yeah.
She's on the same thing Daniel is.
Yeah, this Dexcom and the Tandem. I struggled for a second too, and she is in Boston and used to work at. Was it Joslin?
Yeah, she did research at the Joslin.
Right, in endocrinology, but she's now in psych.
Yeah.
Yeah.
Is her last name Gaffney?
Yeah.
Gaffney with a G.
Caitlin Gaffney. You know the...
Okay, should I? Are there more coming, Simone, or should I get started? Or
I think you should start. Jennifer Gallagher is probably listening in, and she's from the JDRF office. So
okay,
get started. Thank you. And we really, I'll let you introduce yourself and Laurie, who is above, because you'll do a better job of it than I will. But really, thank you so much for taking the time out of your very, very busy and hectic schedule to be with us. We appreciate it.
that's my pleasure. My name's Kevan Herold. I'm a professor of immunobiology and internal medicine at Yale, and I've been here for about 15 years. I was at Columbia before this, and I've been working for the last 3 decades, well, more than that, 4 decades, on the ways of developing new treatments for type 1 diabetes. I mean, that's really been the thrust of what I've done over the years, and a lot of my work is in frankly, is in animal models of the disease, but it's also involved clinical studies. And I'm going to talk about the clinical studies today. A lot of what I'm going to talk about has to do with this TrialNet center that we have at Yale. So TrialNet is a, well, I'll have a slide, but basically it's a consortium that the NIDDK, the National Institute of Health, the Diabetes Division, has put together, and I'm giving you a very biased view about it because I'm going to be the chair of it starting in June. But it is, I think, kind of the, or at least hopefully will become the center of clinical studies for treatment and prevention of type 1 diabetes. And a lot of what I'm going to talk about has to do with screening families, figuring out ways to prevent the disease from happening. But I also want to point out that there's an aspect of this work that's very important for people who have diabetes, because as you probably know, there's been a lot of work going on to try to develop means of replacing beta cells, perhaps with stem cells from another donor, or perhaps even stem cells from the individual who has diabetes. And one of the important things that is going to be necessary is to figure out a way to prevent the immune attack that led to the development of diabetes from recurring in those stem cells. And so a lot of this work, although it's been tested in individuals at risk for diabetes and individuals with new onset diabetes, has relevance for trying to stem the autoimmune attack from reoccurring. And I'm joined by Laurie Feldman, who is our coordinator on TrialNet. And Laurie's been working with me on TrialNet since I first came in 2006. She has a very, very extensive knowledge and expertise in these clinical trials. And so she has really done an outstanding job in developing the center at Yale. One other thing I should mention is that when NIH grants get renewed every few years, and when we did the renewal, what we decided to do was to join forces with our colleagues at Joslin and at Columbia. So now what we have is this this bigger Northeast TrialNet consortia. So the purpose, the importance of that is, our hope was that we would be able to provide services no matter where anyone is in the Northeast part of the United States. And so if there's a trial that, for example, we are offering at Yale that is not being offered at Joslin, individuals could come to Yale for that trial and vice versa. If there's something happening at Joslin that we're not doing at Yale, we have a collaborative relationship, so individuals should be able to freely move back and forth. And if you get tested for things in Boston, we can theoretically see all of that in New Haven. And if there's a study that's available in New York, you could go there for that study. So anyway, our point is to try to make this available to literally everybody in the Northeast. All right, let me, I do want to also talk about some of the work that has happened again, relevant to, like I said, people at risk for diabetes and also people with diabetes. Let me, I can share my screen, I hope. Does that work? Let me flip it over to presentation mode. Can you see my slides?
Yes,
Yes.
And do you see two slides or one slide?
one.
One. Okay, so and okay, all right. So let me talk about a couple of sort of go through this. I'm going to talk a lot about TrialNet. So as I mentioned already, TrialNet is a international network of academic institutions, physicians, scientists, healthcare teams that are involved in type 1 diabetes research. It's funded by the NIH, and one of the main things that we do is we offer screening for relatives of people with type 1 diabetes, and it enables them to participate in clinical studies. The basic goal here is to stop disease progression by preserving insulin production both before and after diagnosis. And I'll talk a little bit more about that later on. So the fundamental concept here is that type 1 diabetes actually develops over a period of years. It's not like, although it clinically presents on a particular day, we know that it actually has been occurring over years before the individual gets to the point where they're actually diagnosed with the disease. And we know that from studies that have followed relatives of people with type 1 diabetes, non-diabetic relatives. And what was found is that before an individual presents with the disease, they have immunologic markers that they will go on to develop the disease. And I think actually since we last had the screening visit, we've now sort of formalized these stages that occur before the onset and after the onset of diabetes. So we measure 5 autoantibodies. These are serologic markers of people who that indicate the immune process that leads to type 1 diabetes. And we know that if you're a non-diabetic relative and you have 2 of these autoantibodies, that you are said, we call that stage 1 diabetes. What we mean by that is that once you have 2 positive autoantibodies, you eventually will go on to develop diabetes. It's a question of when. Now, it may occur particularly in younger people in a couple of months, or in an older individual, it may occur in years. So what the presence of the 2 autoantibodies indicates is that there is a risk for developing diabetes. It doesn't tell us when, but it tells us that the immune response that will eventually kill the insulin-producing beta cells has started. Now, that gives us an opportunity to intervene and try to prevent the disease if we can identify those individuals before they actually have the disease. Now, you wouldn't know who these people are. They feel perfectly normal. They obviously don't take insulin. They don't have abnormalities in their blood sugars. They have hemoglobin A1Cs that are normal. The only way you would know that they exist is by actually looking for these biochemical autoantibodies. Now, if things progress and now the blood sugars are abnormal, if they undergo a glucose tolerance test, they're said to have stage 2 diabetes. If you have stage 1 diabetes, the likelihood overall that you will progress to clinical diagnosis is about 44% in 5 years. If you have stage 2 diabetes, when the glucose tolerance test shows some mild abnormalities, you still don't have diabetes, but you have some mild abnormalities on a glucose tolerance test, the likelihood that you would develop overt disease is about 75% in 5 years. So individuals with so-called stage 2 diabetes are at very high risk for progressing to overt disease. Now, stage 3 diabetes is what we recognize clinically. Individuals may present with diabetic ketoacidosis, they may present with very high blood sugars, but they have clinical diabetes and they need to be treated with insulin. So much of what TrialNet has done is identify individuals at stage 1 and stage 2 diabetes, and also to look in stage 3 diabetes, because drugs that work in stage 3 diabetes may be applicable to these earlier stages. Now, it's taken us, I would say, frankly, a long time to sort of get these concepts into the thinking of regulators and so on. But I do believe that now the FDA has begun to accept this whole concept that this is a progressive autoimmune disease and begins years before the clinical onset. And so perhaps we might be able to do something to prevent the disease from happening. And that's what I'm going to be talking about. So let me just mention one thing that a couple things again about the background and what causes type 1 diabetes. So there is a genetic risk. Diabetes does tend to run more commonly in families, but the overall genetic risk in the population is about 1 in 300. Now, it depends which population you're talking about. It happens to be most common in North American Caucasians. But it occurs in everybody, including African Americans, including Hispanics, including Asian Americans. But overall, the genetic risk is about 1 in 300, and we know many of the genes that are associated with type 1 diabetes. However, let me point out that although families are enriched for the development of diabetes, most people who will develop diabetes don't have a family member who has type 1 diabetes. In families, the overall risk is about 1 in 20. So it's about a 15-fold higher risk in families compared to the general population. But again, most people who will develop the disease don't have a relative with type 1 diabetes. Now, I mentioned already this sort of progression of the disease, starting with the immune activation, the development of these autoantibodies, and then the stages of the disease that we talked about. Stage 1 being when the autoantibodies are present, stage 2 when there's some abnormalities in glucose tolerance. And again, stage 1 and stage 2 is clinically silent. We don't know people have it. Stage 3 is when there is clinical evidence of the disease. Stage 4 is what follows. And generally the thought is that people who develop diabetes eventually go on to complete or near complete loss of their ability to make insulin. Now, there's been a lot of discussion and debate among academic circles as to whether there's any residual insulin-producing cells in individuals even who've had diabetes for 50 years. And, this is kind of a very interesting dilemma or question, because, most immune responses, we know that type 1 diabetes is due to an immune-mediated killing of the beta cells, but most immune responses, when you think about it, like to a virus, including coronavirus, most immune responses occur quickly, briskly, and they kill all of their targets, and then they stop. But in type 1 diabetes, it occurs over years and it just continues. And some people, even after years of the disease, still seem to have some residual insulin-producing cells. Now, why is it that the immune response doesn't just kill all the insulin-producing cells? And the answer to that question is not known. But it's potentially very important, because perhaps those residual cells that haven't been destroyed could be recovered. And so that's obviously an area of intense interest by the JDRF and other groups as well, to see if there's ways of regenerating those beta cells that still may be present even years after the onset of the disease, so-called stage 4 diabetes. Okay, so let me take a step back here. The way that we identify individuals at risk is through this pathway to prevention protocol that TrialNet is sponsoring, and it's a screening protocol. And basically, it involves screening first and second degree relatives, although I have to say that individuals who are eligible for TrialNet studies can get into TrialNet studies any way they screen. And the reason that's of particular importance is because the JDRF has also started a screening program called Type 1 Detect, in which, if you want, you can be screened from your home with a blood spot through a lab that JDRF has made arrangements with. But the TrialNet program is called Pathway to Prevention. It's free. It's free screening for first and second degree relatives. And based on those results, one might be eligible for clinical trials. Now, if you do the JDRF sponsored program, you also are potentially eligible for TrialNet studies. The way that would work is if you're found to be positive in the JDRF program, you might then contact TrialNet for enrollment into this Pathway to Prevention study, which is the direct pipeline into TrialNet studies. So the Pathway to Prevention involves screening individuals between the ages of 2.5 and 45. They can be relatives, basically, or they, as I mentioned to you, they could have tested positive for autoantibodies outside of TrialNet. The way the TrialNet studies works is that you can get a kit sent to your home. You don't have to go anywhere. You can find out about it on the TrialNet website that's shown here. You can get a kit sent to your home. You then can go to Quest or to LabCorp. They'll draw the blood, send it into the TrialNet lab, and it gets run. Now, so that's kind of the entry into the program. And the person, of course, who's coordinating all of this is Laurie, who I introduced. This is how you can contact her. You can also go on the website, like I mentioned. Now, why should you do this? And the reason...
May I just ask a quick question?
Sure.
You mentioned that the screening is between the ages of 2, or then you said 2.5 to 45, but it used to be younger. Can you tell us?
You mean why it's not down to age 1 or date? I actually thought, Laurie can correct me on this, I actually thought it was 3 originally. Laurie, do you recall?
It was originally 1. Then when we had a big protocol update a few years ago, they switched it to 3, 2.5, because one of the motivating factors was that our prevention studies tend to start no younger than 3. And so it made sense to start at 2.5. By the time you're tested and might be eligible for a prevention study, you would be close to 3.
Laurie brings up a point that is a good introduction to one of the other things I want to talk about is, to be honest, so one of the things I tell people is that, the screening is very helpful because most people are going to screen negative. And if you screen negative, or even if you screen and you find that you have a single positive autoantibody, the likelihood that you're going to develop diabetes over the next 10 years is very small. So for most people, it's a way of reassurance. And for those who are positive, it provides the opportunities for prevention trials. Now, there's no point in screening, frankly, if there are no prevention trials or nothing you can do about it. I mean, there's no reason to be searching out, news that can be disturbing, but I think that has changed. So that's what I want to talk about next. I want to talk a little bit about the work that TrialNet has done on this drug called teplizumab. So I don't want to give you, I don't want to go into a lot of the medical details about it, but just suffice it to say that this is a drug that targets immune cells, T lymphocytes, that we think are responsible for killing insulin-producing beta cells. And there's a long story on the development of this, and it started actually 30 years ago with a colleague of mine, Jeff Bluestone, and me at when we were at the University of Chicago, in terms of developing a way of stopping the immune response that leads to the development of diabetes. And eventually it led to the production of this drug that has a number of unique immune features about it. And I don't think there's much point in going into the details, but it turned out that beginning with mouse studies, it moved to early human clinical trials that I did when I was at Columbia, and then eventually led to companies doing trials. And then finally, these trials look very good in people with new onset diabetes. And finally, the question that was asked was, well, if it seems to have benefit for people with new onset diabetes, it did in these early clinical trials, would it be able to prevent diabetes in people who are at risk? And so TrialNet started this trial, which is called TN10, in 2011. And the purpose of the trial was to determine whether, if you took individuals before they had diabetes, at stage 2 diabetes, and treated them with this drug, teplizumab, would you prevent or delay the diagnosis of diabetes? And this is the way the trial unfolded. Again, I'm just showing you this for orientation. There were people screened in the Pathway to Prevention trial, and there were 76 people from the screening who were randomized to either receive drug or placebo, and they were treated with one or the other, and then they were followed for until they developed diabetes, or until the trial stopped. And there are some details about the statistical analysis I don't think I need to go into, but let me just say that the way that the trial was set up is we randomized people, we treated them, and then we followed them until there were a total of 42 events. In other words, 42 people in the trial developed diabetes. And then we asked, are more of the people in the drug or in the placebo group? That's basically how it was done. So here's the results of that trial. Let me make a couple points about this. First of all, if you take a look at the placebo group that's in the red line, we're looking at the rates of progression of diabetes. This is a so-called Kaplan-Meier curve. It's pretty standard stuff for analyzing clinical trials. So if you look, the y-axis here is the proportion of individuals who are type 1 diabetes free. Remember, so this trial enrolled people with stage 2 diabetes. Remember, they don't have diabetes. So you can see on the y-axis, on the left side of this graph, 100% of the people when they go into the trial don't have diabetes. And then the placebo group is in red, and you can see that the median time, half of the people developed diabetes in 27.1 months. In other words, one point that's made in the placebo group here is that our ability to predict the onset of diabetes is spot on. Based on the data that I told you about earlier, we had predicted that 75% of people with stage 2 diabetes would develop diabetes in 5 years. And this actual data shows that half of the people develop diabetes in 2 years. And if you take a look at the graph, even out to 5 years, 60 months, the x-axis shows time in months. 60 months, you can see that it's getting pretty close to about 75% of people are developing diabetes in 5 years. So the prediction of diabetes is quite accurate. In the drug-treated group, the development of diabetes was significantly delayed. It was delayed out to about 6 years, to 5 years, 60 months, or about a 3-year delay in the time to diabetes. But I want to make a couple points about the drug-treated group. So it turned out at the end of the trial, half of the drug-treated people did not develop diabetes. Now, whereas only 22% of the placebo people had not developed diabetes. Now, we don't know what's going to happen to that half that didn't develop diabetes. It could be that the day after we stop the trial, all of them develop diabetes. I don't think that's true, but that always is a possibility. Or it could be that at least some of them will never develop diabetes. So we're trying to follow those individuals to find out what will eventually happen to them. Will they ever develop diabetes, or will they never develop diabetes? Now, the other thing I want to emphasize here is that you could say, oh, well, this doesn't look so good. Everybody's sort of progressing to diabetes. And I mentioned to you, we don't know what happens to those that did develop diabetes. But there's one other point to be made. If you think about this in terms of other clinical studies and, or even fields where drugs are being introduced for the first time. Let's take cancer as an example. When we do cancer trials and you test a new agent, it's not like you test a single agent and now all of a sudden everybody doesn't develop cancer and everybody's cured and the disease is gone. That's not the way things work in medicine. We usually start with there being some evidence of a good clinical effect in some proportion of individuals. And based on that first step, other things develop. You add drugs to it, you retreat with drugs. And so I want to suggest that this is sort of that very early stage that we might think about in treatment of other diseases, where we have a first step of success, and then there are opportunities to build on this. So the FDA liked this data, and they actually gave it breakthrough designation, and the European agency, the EMA, gave it prime designation. And there is an advisory council at the FDA that's going to be held on May 27th. And, we're very the fact that it was given breakthrough designation is, makes the FDA helpful in terms of trying to get the drug approved. If it is approved, it would be the first drug to actually change the natural history of type 1 diabetes. Remember, 100 years ago, insulin was discovered. And up until then, type 1 diabetes was an immediate lethal disease. There has never been, and I would include among that, a treatment that would change the course of diabetes. Insulin is, some people refer to it as a Band-Aid. Of course, it's a lifesaver. It saves the lives of people with diabetes, but it doesn't change the course of the disease. But this is a different type of an approach. So to summarize where this is, so the results of the trial showed that a single 2-week treatment delayed the onset of diabetes in non-diabetic relatives at very high risk for developing clinical type 1 diabetes. The median time in the delay was 3 years. Half of the drug-treated people still didn't have diabetes at the end of the trial, compared to 78% of those treated with placebo. It can be safely administered to children and adults. I didn't show you all that data. This is the first trial to show that immune therapy can delay or even prevent type 1 diabetes. And the 3-year delay is clinically important. And I just, it's funny because sometimes when I talk to people who don't have diabetes or don't know what it's like to have diabetes, this always ends up being an area of discussion. And, you can see the words, in light of the daily burden, it's very important to not have diabetes. And I tell them, I think people with diabetes will tell you, I'll do anything for a month without diabetes, for a week without diabetes. And I'm always reminded of what, I had a colleague at Columbia, one of the diabetes educator there, who had diabetes, and the two of us, this is back in the early days, would always sort of talk about what we would do if diabetes was cured, or we didn't have diabetes. What are we going to do? And this colleague of mine told me that he knows exactly what he's going to do, and you have to know the setting here a little bit. This was at the Naomi Berry Center, which is on the Upper West Side in Manhattan. And if you look outside the window, there's this little. This is where St. Nicholas Avenue and Broadway kind of intersect, and there's this little triangle that has some grass in there. And in the city of New York, they call that a park, and they put a park bench on there. So this colleague of mine said, you know, I know exactly what I'm going to do. I'm going to go out to that park and I'm going to sit on that bench. And I'm not going to do anything. I'm not going to test my blood sugar. I'm not going to worry about what I ate. I'm not going to worry about what activity I did to get here. And I'm not going to worry about what I did next. I'm going to do nothing. And I think, you know, his goal here really kind of captures what it means to not have diabetes. It enables you to do nothing. All right, so where are we going to go with this? You know, I think as I mentioned to you, I think this is a first step, and there's a whole lot of ways to go. Let me just point out this sort of conceptual depiction, which a colleague of mine, Colin Diane, drew. And what it does is it describes the stages of diabetes from no metabolic risk when you don't have diabetes, that's in green on the top of this graph, to when you have new onset diabetes, it's low metabolic risk, you can still make some of your own insulin, down to the very bottom when you make none of your own insulin. And that's when the course of the diabetes is very labile. You're at risk for hypoglycemia, hyperglycemia. You're completely dependent on the insulin that you inject for metabolic control. And on the left Y panel here is the stimulated C-peptide concentration. We can ignore the numbers, but it reflects how much of your own insulin that you make. The natural course of the disease is depicted in the black line on the left, which is to lose your ability to make insulin over time. Now, we've done trials for people with new onset diabetes, that's the red arrow, and we can change the course of the disease after people have developed type 1 diabetes, and it delays the time that it takes to get to that the red period of time, which you're trying to avoid. Now, in this new trial, we treated people before they developed diabetes, and you can see that results in an even greater delay in the period we think will result in an even greater delay, even if you develop diabetes, in the time at which you get to this very high metabolic risk state. But the other possibility is to treat people before diabetes, and if they do develop diabetes, treat them after they've developed disease, and it may be that you may never get to a period of very high metabolic risk. Or if you do, you're only going to get there way after a period of time, or after, if you're a child about to go into middle school, way after you've graduated from college, or way after you've left high school, a period of time when you might be able to better accept the management of the disease. So I think that's potentially where we want to go with this. So I want to just then sort of mention a couple of other clinical trials that are ongoing through TrialNet. And this one, this hydroxychloroquine trial is still recruiting individuals at stage 1 diabetes. These again are people who have normal blood sugars. They have positive autoantibodies. We know they are at risk for developing diabetes, 44% in 5 years. That trial is still open, and we're very eager to recruit individuals. That recruitment will probably close over the course of the next year. Another trial that we're doing is with a drug called Orencia or abatacept, which is for people, again, with autoantibodies but normal glucose tolerance. The question is, can we prevent them from going into the next stage of diabetes? And again, this would open up a new frontier in trying to prevent the disease. It's been fully enrolled. There should be data coming out in the coming year about it. And again, if this changes the course of disease, it would be definitely paradigm shifting. And then lastly, this trial called TOPPLE, which is a early phase trial, but it uses a strategy for immune modulation. It's not the same kind of immune modulation that I've talked about up to now, but this is one that we think would be very good to go into prevention of disease. We're first doing it in people with new onset type 1 diabetes, and as you can see, it's enrolling adults between the ages of 8 and 45 who've been diagnosed within the past 4 years. So a very broad window of enrollment. Let me just close with this, where I think we want to go. And I mentioned this idea of treating at different stages of the disease, but these graphs make another point that I think is worth bearing in mind. The vast majority of people who will develop type 1 diabetes do not have a relative with the disease. Most people are found in the general population. Now, the data on the right side here, it's data from Annette Ziegler that was done in Germany, and in which she showed that, and this is what I've referred to, that once you have two of the, in this case, she measured a total of 3, but 2 of the biochemical autoantibodies, that you will go on to develop diabetes. And you're looking at the age of the subjects on the x-axis and the probability that they'll develop diabetes on the y-axis. And you can see once you have 2 or more, 2 or 3, that you are very, very likely to go on to develop diabetes. On the left side is a project that was done in Bavaria, Germany, in which all of the children in Bavaria were screened by their primary care pediatricians for the presence of autoantibodies. And what they found was that about 0.3% of the children were positive for autoantibodies. And the point that is made in the data here is that their risk of developing diabetes is the same as relatives over the course of, in this case, 4 years. The circle on the right-hand side of the graph shows the data that's the same period of time that's shown on the left side of the graph in the the general population. So I actually think that the next frontier here is to begin to think about whether we should be screening the general population for the risk of diabetes, because there's something we can do about it now. I wouldn't have said that 2 years ago when there was really nothing to do about it, but that has completely changed. And so, you know, I in my introductory comments, you know, what I'm sort of hoping about is that, you know, the Wikipedia feed for type 1 diabetes and for TrialNet is that, you know, you need to, is that this used to be a disease that affected children, but people of, largely children, but people of all ages, that was prevented by immune therapy. And, you know, I'm actually keen to say that TrialNet is responsible for doing it, but I think, you know, we're at a time point now where we can begin to think about doing this. And, you know, hopefully very exciting things will be coming. So I'm going to stop there, and I'm happy to answer any questions you may have. Go ahead.
My question is whether there's any long-term, like, you know, we talk about immunosuppressants. Does this suppress the entire immune system for the rest of your life, or is it something that's more targeted towards type 1?
Yeah, so that's a critical question. So let me just mention one thing. So the rules here are that chronic immune suppression is a non-starter for even if you could give chronic immune suppression and a person never was diagnosed with diabetes, that wouldn't have a favorable risk benefit ratio. And the reason, you know, the reasons for that. So the way the drugs that are being tested are working are they're given for a brief period of time. The teplizumab that I mentioned is given for, well, now it's given for 12 days, and then that's it. Then you are followed. Now, we know there are some changes in immune cells, and we know that we believe that the changes seem to be fairly specifically directed towards cells that we believe are responsible for killing the insulin-producing beta cells and not affecting general immune function. And the reason I say that is that we know that individuals that are treated can very adequately get rid of viral infections, for example, EBV, and there's no evidence that there's an increased rate of even colds after, you know, or other upper respiratory infections after they've been treated. So, and the drug is gone after a month. So the answer to your, you know, the answer is obviously that's an area of intense concern and interest, but it's not given chronically, and we don't have evidence that there will be sort of persistent impairment of immune responses. Any other?
I don't have a question. I actually have a comment. I think this is so great if they would make it to where the testing was across the board, because even with my daughter, we knew something was weird for years actually, because she kept like throwing up randomly every time when she would eat, and I'm sure it was you know, they misdiagnosed her, you know, whatever, and then she had an ear infection, blah blah blah. So I know I'm not alone in thinking like, oh, if they could just do a test, because she was, you know, 4, she would have been the right age. Like that would be awesome, and I'm very excited about this. So
yeah, I mean, you know, the JDRF type 1 T1 detect program, you know, does enable that, but you know, the other point being that, you know, there's also trial. If you're a relative, you can certainly go right into TrialNet, but if you're not, then the JDRF program offers a real opportunity.
yeah, and I mean, I can't wait for it to just be like a standard thing. You know what I mean? Like, I feel like you still have to ask for it, which sucks, I think. Because, you know, I mean, I would imagine it would be a little bit like, I have a headache, I have a brain tumor for most doctors. Like, you know what I mean? Like, but if they had this information and then they were able to jump on it with medication, I think that's great.
Yeah. Yeah, you know, I think there's a huge sort of outreach need to make people aware of what's possible and where the field has gone.
So my follow-up question, I think all of us, well, Kimberly maybe, her little boy was diagnosed recently, but like my son's had this for 9 years, 8 years, I can't keep track, 2013 to 2021, so 9 years, 8 years. Is there anything hopeful for people who've had it for a while?
So I can tell you that one of the things that I mean, my lab is involved in is test. This is a no-brainer thing, which is to test whether that drug, teplizumab, would prevent rejection of transplanted stem cells. And, you know, I'm sure you're aware of the work that Doug Melton's group has done, and that's been sold, you know, and has been developed. And there are early clinical trials that are starting now to use those products. But I think the question is going to be, well, are the immune protective strategies that are going to be part of the product going to be sufficient, or do you need something like this as well that will stop recurrence of disease or even rejection? Now, this drug has been tested in islet transplants and it works very well. So, you know, I'm keen, hopefully next month we'll start some of the preclinical studies to test this question.
I just am wondering what you would say to a pediatrician who, you know, if a young infant or a 1-year-old has a dad with type 1 and the pediatrician says, well, you know, just randomly take their blood sugar, do a finger prick. What is your response to that?
So I guess my response, to tell you the truth, would be that's not adequate. Because that tells you someone's right about to go over a cliff, you know, I would never say this, but you know, we don't do heart transplants on dead people, and why would you wait until somebody has diabetes to you know, to figure this out? Now, I wouldn't say anything if there was nothing we could do about it, but I think in terms of, you know, going forward, I think I would get screened.
But you have to wait till you're 2.5 to be screened, right?
Yeah. Now, if teplizumab is approved, you know, keeping our fingers crossed, if it is approved, it will be down to age 8. the company will do a trial. They're going to have to do a trial in younger individuals. And the FDA has said they want to go very young, like, less than 3. I mean, I don't know. There's a practical aspect of this, giving drugs to, very, very, very young children. I mean, I'm not a pediatrician, but so maybe my colleagues would do it. But you're right. You have to wait until you're some reasonable age to be involved in that. That is an important thing, and my colleague Annetta Ziegler, I mentioned some of her work, has made that point many times. The big increase in the rates of diabetes are happening in the very young, and we have absolutely nothing to offer them, unfortunately.
Dr. Herold, so that's my mom. I believe she's probably talking about my situation. My daughter turned 1 yesterday. So, and I'm type 1. I know you can't screen until 2.5, but the other question I would have is, so I'm not sure if you're familiar, but my daughter has something called FPIES, which is sort of an allergy disorder. It's autoimmune. Are there any other signs, any other autoimmune diseases that would sort of suggest that she will have type 1? And is there any screening for that you could do sooner? Like, I know they say with FPIES, often, you have eczema as well, and things like that. Is there any correlation with other autoimmune diseases?
Well, there is. There are fairly uncommon disorders. For example, there's one called the IPEX syndrome that occurs in boys. But that is linked to the loss of a gene that's responsible for production of regulatory T cells that control the immune response. And then there are sort of variations on that same theme. There are autoimmune syndromes. One is called APS, or the autoimmune polyglandular syndrome, that are linked to particular genes, where, for example, thyroid disease occurs commonly with type 1 diabetes. Those, although APS is not uncommon, some of these other specific genetic mutations are much less common. I don't know for sure with that particular mutation. I'd have to look that one up. There are examples. I'd have to look it up, though.
Thank you.
Daniel is so exciting to put a name to the face. In a positive way. She only says good things.
Right. And you're very handsome. So it's nice to see your face. We've heard about you for years. How uncomfortable are you now?
He's like turning the camera off.
I was just quietly creeping on mute. I'm on a work call as well, so I'm trying to build Zoom meetings, which is not as easy as it sounds.
Yeah.
But no, I definitely wanted to ask that. I know my wife was curious as well. Because it's too bad that the screening can't happen till 2.5. But I guess it makes sense. I heard you say earlier it's because the preventative studies don't start until 3. And
I don't know what the lower age is for the type 1, for the T1 Detect program in the JDRF. It may be younger, and it just involves a blood spot, so that's real easy.
I'm going to look that up right now.
Yeah, I should know that. I don't know that.
You mean through JDRF?
Yeah. Give me 2 seconds and I'll tell you.
Other people have questions while Susan's looking that up?
It says any age. So I think anybody can order a test. I'm just trying to see.
So that's an idea.
And the only caveat I would have is I know when we listened to Dr. Diane talk, he was saying that once they're like 2.5 or 3, that most people that are going to have the 2 autoantibodies have them, but younger than that, they might still develop the 2. But,
Yeah. You know, there's a fair amount of work going on now to figure out when, if you had to do it once, when should you do it? And it probably is closer, you know, it's probably in the 3 to 5 range if you had to do one. I can tell you in Germany, what their plan is to screen very young at 2, and then to and then rescreen in a couple of years later. So you're right. So most kids will declare themselves fairly young. It's much less likely that somebody will be negative out to say 8 years of age and then all of a sudden become positive when they're 18. Yeah, I mean, early identifies a very high proportion of individuals.
It does look like, Daniel, you could just order a test through T1 Detect. And if you just Google that, there's a cost, it's $55 or $65, but might be worth it for peace of mind. And maybe just do it annually until you're eligible for the free test.
Yeah.
Yeah, it's not a bad idea.
Are they, sorry, I came late. Do they look for the same thing?
So, you know, there's been a lot of discussions about this. The T1 Detect test, which uses blood spots, uses a test that's being done by a lab called Enable. And it's the method is very, very good. The blood spots raise some question because it's never been validated in the same way that the serum samples, the blood samples have been validated. Nonetheless, so the method is very good. And I don't mean to say it's not good. It just hasn't undergone the same validation studies that are done in the various workshops that validate these tests. So the impression that I've had is that it seems to be less likely to miss positives, but the positives need to be confirmed with the other tests.
Okay.
I have a question. I know my daughter would love to see the recording of this. And how do you get the recording?
I can get that to you. It is being recorded. So if I'm sure we have your email address, but I'll before we hang up, I'll make sure that I have it and I can send it out. No problem.
Thank you.
Could you possibly send it to the group emails or the Simone or Lynn so we could share it with our other members who were not able to attend today?
Absolutely.
I would just send it to the coffee group. And if people want to delete it, you know, that's fine. But there probably are a number of people who would like to look at it. Thank you. Any other questions for Dr. Herold about this? Hi, Kathy. Nice to see you. Laurie, thank you for all you do. For those of you who don't know, Laurie is retiring at the end of the year. So we are going to miss her. She's been a great resource to so many people over the years. Is there anything you want to add about people reaching out to you or TrialNet, Laurie?
While they can reach out directly through the website, the public website, I'm always happy to talk directly to people to answer their questions as best I can, or to refer them to Dr. Herold or someone else for the appropriate answer. Even if it's been something that's been covered, and they shouldn't hesitate to contact me, either through the email or the phone number.
So just following up on that, I think at the very beginning of the presentation, and some of you might have missed this, Dr. Herold was saying that TrialNet was coordinating with Joslin and I can't remember who else. So there could be a study in Boston and New York that you might be able to help people with scale. Is that correct?
Well, we coordinate on several levels, mostly TrialNet, but other studies as well. Yeah. So within TrialNet, you can always transfer from site to site, whether or not you're part of this Northeast Consortium. TrialNet is across the country, So I wouldn't want people to say, well, my child lives in California and they can't participate. They can. So if there are any questions, just contact me. I'm happy to respond.
Are there other studies that you are aware of that might be being held in currently?
I'm sorry, I didn't hear you. There seems to be some interruption.
Are there other trials close by that might be happening that might be pertinent to members of our group that you might be aware of?
There are other studies, new onset studies.
Okay.
It seems this particular group that's listening today have children or relatives with long-standing diagnoses, but Dr. Herold is the principal investigator of other new onset studies.
Okay.
That are non-trial net.
Yeah, we've had a bunch of new families recently, so that might be pertinent. We'll give your information out to them. Thank you.
Yeah.
There is a trial called PROTECT, which is a phase 3 trial of the same drug that I showed you delayed the onset of diabetes. It's enrolling people with new onset diabetes. And it's mostly children. In fact, it's only children. And it's children within the first 6 weeks after the diagnosis of diabetes. So it's important to make sure the word is out quickly.
Okay.
And for anybody who's interested in trials, if you go to the JDRF website, they have a whole, and I can send the link, but they have an entire, you type in your name, or you don't have to give them a name, but your age, when you were diagnosed, where you live, and it'll show you what trials are in the neighborhood, or, you can give it parameters that you might be eligible for.
Well, that's good to know, because when JDRF sends out Bag of Hope for newly diagnosed patients, it seems to me that PROTECT study should somehow we should let people know about that, since there's a 6-week time frame. So Cheryl, I don't know if that's something that JDRF does, but it certainly sounds like that could be really critical. Yeah.
I certainly agree.
Okay.
I just put the website link into the chat for finding clinical trials through the JDRF site. But when I typed it into Google, the Yale site came up too. So it's not hard to find.
Okay, great.
Thank you, Susan.
Dr. Herold, if there aren't other questions or comments, really, this has been just fantastic. There's so much going on. It's hard for us to know, especially in this COVID world. We don't get together, but Zoom has certainly been a great option for us. We really thank you from the bottom of our hearts taking the time to chat with us and impart your words of wisdom and the studies that are going on. It's so helpful. Really appreciate it.
Oh, thank you. Thanks for having me. My pleasure.
And Laurie, thank you. And hopefully we will chat with you before you retire.
For sure.
Or part-time.
For sure.
I haven't accepted it yet, but and you notice I have no slide about it, so.
Right. Okay. We're in denial, I think. Okay.
That's right. You got that.
Thanks so much. We really appreciate it. And we'll all go to the website and read about some of these studies. And thank you again. Appreciate it.
All right. You're welcome.
Bye, everybody.